In this lesson, we're going to talk about vectors. Now, vectors are used often in physics, and I'm going to give you a different definition than what's written below. The one that's written below will help us in terms of the math, but vectors in general are quantities that have length or size sometimes that's also called magnitude, the magnitude of the vector, which we'll see later, and direction. Okay, so vectors have length, which you can interpret as meaning size or magnitude. Those terms are interchangeable. And direction. Compare that with the definition of what's called a scalar, which just has size. Okay, just has size. Or length or magnitude or direction. So an example would be, if you think about speed, right? If you throw a ball up in the air, maybe at one point it's going 20 miles per hour, right? It's going 20 miles per hour on the way up, and then on the way down at another point it's going 20 miles per hour. We would say that the speed of that ball in both cases is 20 miles per hour. Notice that doesn't specify the direction. So on the way up and on the way down, the speed is the same. However, as a vector, on the way up, it's going 20 miles per hour up, and on the way down, it's going 20 miles per hour down. Those are considered two different quantities when you describe them as vectors. Okay, so that's just one of many examples. In terms of the math or relating to the geometric interpretation of a vector, I put down this definition, which I think will help us as we deal with the geometry of these vectors. So you can view a vector in the math sense as a directed line segment that corresponds to a displacement, and a displacement just means change in position. Change in position. A displacement from one point in this diagram here, A, to another point, B. So this vector here starts at point A and ends at point B. And how do I know it starts at point A? Well, because the arrowhead is up here at B and not down here at A. So if you want to, one thing to think about when you're considering vectors is, if you were to travel along it, how would it move you, right? If you started at A and traveled along the vector, it would move you from A to B. So some terminology, where the vector starts is called the initial point, but we often just use the word tail. And where it ends is called the terminal point, but we often just use the term head. Over here to the right, O, B, A, and C, those are points. Okay, those are just points in the XY plane. The vector that takes you from O to A, point O to A, we often will just call that vector A. And see, I gave it a little, I put a little lowercase a here, and I put this like half of an arrow. Sometimes you put a full arrow, but to name vectors, what we do is we put the letter down, and we'll put an arrow over it so that we know we're talking about a vector, not just a point. Sometimes books just put the letter in bold, but you know, either is appropriate. So just a few different ways you can name vectors. Let's look at vector A here. Vector, let's get more weight to this marker. Vector A. One way to name it is just give it a letter, you know, and put an arrow over it, or a half arrow. What you could also do is say the vector starts at O, point O, and ends at point A. And to describe that it's going from O to A, we'd put the arrow starting at O and going towards A. So vector B, we could say it starts at O, ends at B, And likewise with vector C. Starts at O, ends at point C. Okay, so those are just different ways of naming vectors. It's more useful typically to just give it a letter name and put the, give it a letter name like A, B, C, or U, or V, or common, and put the arrow over it. But you want to be familiar with this notation here as well. However, the most useful notation is what's called component form. And so this is going to be really important. So let's look at vector A here. If you were on it, you'd start at point O, you'd travel along the vector, and you'd end at point A. Let's describe how you'd travel. As a vector, what we would do, and there's many different notations, but in our course we're going to use these sort of sideways pointy brackets here, or these pointy brackets. To travel along vector A, you start at point O, it moves you 3 to the right and 2 up. So we would say vector A, or OA, can be written as 3, 2. Notice the pointy brackets distinguish it from a point. And if it's rounded brackets, it would obviously just describe the point 3, 2. But with the pointy brackets, that means this is a vector that moves you 3 to the right and up 2. Vector OB moves you left 1 and up 3. So we'd write it as -3, -1, 3 rather. And OC moves you right 2 and down 1. So we write that as 2, -1. This is called the component form of the vector, these here. Component form. And the 3, let's get the highlighter out, the 3, the 2, the 3, the -1, and the 2 are called the x components, which makes sense. They kind of correspond to the x coordinate of the point where they end. And I don't want to color up the number too much, but these are the y components. Alright, so this lesson was just an introduction to tell you what a vector is, some terminology, and how we label them, different ways to name them. There's more to do, so in the next few videos we'll get more of the details down.